wishes to all of you. Fundamentals of Physical Geography, textbook for class 11, ninth chapter, Solar Radiation, Heat Balance and Temperature, audiobook. Do you feel air around you? Do you know that we live at the bottom of a huge pile of air? We inhale and exhale, but we feel the air when it is in motion. It means air in motion is wind. You have already learned about the fact that Earth is surrounded by air all around. This envelope of air is atmosphere which is composed of numerous gases. These gases support life over the Earth's surface. The Earth receives almost all of its energy from the sun. The Earth in turn radiates back to space the energy received from the sun. As a result, the earth neither warms up nor does it get cooled over a period of time. Thus, the amount of heat received by different parts of the earth is not the same. This variation causes pressure differences in the atmosphere. This leads to transfer of heat from one region to the other by winds. This chapter explains the process of heating and cooling of the atmosphere and the resultant temperature distribution over the earth's surface. Solar radiation. The Earth's surface receives most of its energy in short wavelengths. The energy received by the Earth is known as incoming solar radiation, which is short is termed as insolation. As the Earth is a geode resembling a sphere, the sun's rays fall obliquely at the top of the atmosphere and the Earth intercepts a very small portion of the sun's energy. On an average, the Earth receives 1.94 calories per square centimeter per minute at the top of its atmosphere. The solar output received at the top of the atmosphere varies slightly in a year due to the variations in the distance between the Earth and the Sun. During its revolution around the Sun, the Earth is farthest from the Sun 152 million kilometers on 4th July. This position of the Earth is called aphelion. On 3rd January, the Earth is the nearest to the Sun 147 million kilometer. This position is called perihelion. Therefore, the annual insolation received by the Earth on 3rd January is slightly more than the amount received on 4th July. However, the effects of this variation in the solar output is masked by other factors like the distribution of land and sea and the atmospheric circulation. Hence, this variation in the solar output does not have great effect on daily weather changes on the surface of the earth. Variability of insolation at the surface of the earth. The amount and the intensity of insolation vary during a day, in a season, and in a year. The factors that cause these variations in insolation are the, rotation of Earth on its axis, the angle of inclination of the sun's rays, the length of the day, the transparency of the atmosphere, the configuration of land in terms of its aspect. The last two, however, have less influence. The fact that the Earth axis makes an angle of 66 and a half with the plane of its orbit round the Sun has a greater influence on the amount of insolation received at different latitudes. The second factor that determines the amount of insolation received is the angle of inclination of the rays. This depends on the latitude of your place. The higher the latitude, the less is the angle they make with the surface of the earth, resulting in slant sun rays. The area covered by vertical rays is always less than the slant rays. If more area is covered, the energy gets distributed and the net energy received per unit area decreases. Moreover, the slant rays are decreases. Moreover, the slant rays are required to pass through greater depth of the atmosphere, resulting in more absorption, scattering, and diffusion. Take a look at figure 9.1. Summer solstice, south to north, the passage of solar radiation through the atmosphere. 66.5 degrees, 23 and a half, the Tropic of Capricorn, night equator, day Tropic of Cancer 23 and half in 19 degrees, 47 degrees, 66 and half, 23 and half degrees north sunrise. The atmosphere is largely transparent to short wave solar radiation. The incoming solar radiation passes through the atmosphere before striking the Earth's surface. Within the troposphere, water vapor, ozone, and other gases absorb much of the infrared radiation. Very small suspended particles in the troposphere scatter visible spectrum both to the space and towards the Earth's surface. This process adds color to the sky. The red color of the rising and the setting sun and the blue color of the sky are the result of scattering of light within the atmosphere. Spatial distribution of insolation at the Earth's surface. The insolation received at the surface varies from about 320 watt by meter square in the tropics to about 70 watts meter square in the poles. Maximum insolation is received over the subtropical deserts where the cloudiness is the least. Equator receives comparatively less insolation than the tropics. Generally, at the same latitude, the insolation is more over the continent than over the oceans. In winter, the middle and higher latitudes receive less radiation than in summer. Heating and cooling of atmosphere. There are different ways of heating and cooling of the atmosphere. The earth, after being heated by insolation, transmits the heat to the atmospheric layers near to the earth in long wave form. The air in contact with the land gets heated slowly, and the upper layers in contact with the lower layers also get heated. This process is called conduction. Conduction takes place when two bodies of unequal temperature are in contact with one another. There is a flow of energy from the warmer to cooler body. The transfer of heat continues until both the bodies attain the same temperature or the contact is broken. Conduction is important in heating the lower layers of the atmosphere. The air in contact with the earth rises vertically on heating in the form of currents and further transmits the heat of the atmosphere. This process of vertical heating of the atmosphere is known as convection. The convective, the convective transfer of energy is confined only to the troposphere. The transfer of heat through horizontal movement of air is called advection. Horizontal movement of the air is relatively more important than the vertical movement. In middle latitudes, most of diurnal day and night variations in daily weather are caused by advection alone. In tropical regions, particularly in northern India during summer season, local winds called Lu is the outcome of advection process. Terrestrial radiation. The insolation received by the earth is in short waves forms and heats up its surface. The earth after being heated itself becomes a radiating body and it radiates energy to the atmosphere in long wave form. This energy heats up the atmosphere from below. This process is known as terrestrial radiation. The long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and the other greenhouse gases. Thus, the atmosphere is indirectly heated by the Earth's radiation. The atmosphere in turn radiates and transmits heat to the space. Finally, the amount of heat received from the sun is returned to space, thereby maintaining constant temperature at the Earth's surface and in the atmosphere. Heat budget of the planet Earth. Take a look at figure 9.2, heat budget of the Earth. Shortwave solar radiation, longwave earth radiation. Total solar radiation scattered to space minus 6, scattered radiation plus 17 absorbed by the earth plus 34 absorbed by the earth. Direct clouds radiation 100% plus 14 absorbed by atmosphere Reflection by space minus 27 by clouds minus 2 by earth. Long wave earth radiation minus 23 radiation from earth plus 6 to minus 17 radiated to space from earth. Minus 9 plus 9 turbulence and convection. Minus 19 plus 19 condensation radiated to space by atmosphere minus 48. Here, Figure 9.2 depicts the heat budget of the planet Earth. The Earth as a whole does not accumulate or lose heat. It maintains its temperature. This can happen only if the amount of heat received in the form of insolation equals the amounts lost by the Earth through terrestrial radiation. Consider that the insolation received at the top of the atmosphere is 100%. While passing through the atmosphere, some amount of energy is reflected, scattered, and absorbed. Only the remaining part reaches the Earth's surface. Roughly 35 units are reflected back to space even before reaching the Earth's surface. Of these, 27 units are reflected back from the top of the clouds and 2 units from the snow and ice covered areas of the Earth. The reflected amount of radiation is called the albedo of the Earth. The remaining 65 units are absorbed, 14 units within the atmosphere, and 51 units by the Earth's surface. The Earth radiates back 51 units in the form of terrestrial radiation. Of these, 17 units are radiated to space directly, and the remaining 34 units are absorbed by the atmosphere. 6 units absorbed directly by the atmosphere, 9 units through convection and turbulence, and 19 units through latent heat of condensation. 48 units absorbed by the atmosphere, 14 units from insolation plus 34 units from terrestrial radiation are also radiated back into space. Thus, the total radiation returning from the earth and the atmosphere respectively is 17 plus 48 is equal to 65 units, which balance the total of 65 units received from the sun. This is termed the heat budget or heat balance of the earth. This explains why the earth neither warms up or nor cools down despite the huge transfer of heat that takes place. Variation in the net heat budget at the earth's surface. As explained earlier, there are variations in the amount of radiation received at the Earth's surface. Some part of the Earth has surplus radiation balance while the other part has defect. Take a look at figure 9.3. Latitudinal variations in net radiation balance. Latitude, energy, watts, meter square. Terrestrial radiation, solar radiation, deflect, surplus, deflect. Figure 9.3 depicts the latitudinal variation in the net radiation balance of the Earth the atmosphere system. The figure shows that there is a surplus of net radiation balance between 40 degrees north and south, and the regions near the poles have a defect. The surplus heat energy from the tropic is redistributed polewards, and as a result, the tropics do not get progressively heated up due to the accumulation of excess heat, or the high latitudes get permanently frozen due to excess defect. Temperature. The interaction of insolation with the atmosphere and the Earth's surface creates heat with it, which is measured in terms of temperature. While heat represents the molecular movement of particles comprising the substance, the temperature is the measurement in degrees of how hot or cold a thing or a place is. Factors controlling temperature distribution. The temperature of air at any place is influenced by the latitude of the place, the latitude of the place, the latitude of the place, the altitude of the place, distance from the sea, the air mass, circulation, the presence of warm and cold ocean currents, local aspects. The latitude. The temperature of a place depends on the insolation received. It has been explained earlier that the insolation varies according to the latitude, hence, the Temperature also varies accordingly. The altitude. The atmosphere is indirectly heated by terrestrial radiation from below. Therefore, the places near the sea level record high temperature than the places situated at higher elevations. In other words, the temperature generally decreases with the increasing height. The rate of decrease of temperature with height is termed as the normal lapse rate. It is 6.5 degrees C per 1000 meters. Distance from the sea. Another factor that influences the temperature is the location of a place with respect to the sea. Compared to land, the sea gets heated slowly and loses heat slowly. Land heats up and cools down quickly. Therefore, the variation in temperature over the sea is less compared to land. The places situated near the sea come under the moderating influence of the sea and land bridges, which moderate the temperature. Air mass and ocean currents, like the land and sea bridges, the passage of air masses also affects the temperature. The places which come under the influence of warm air masses experience higher temperature, and the places that come under the influence of cold air masses experience low temperature. Similarly, the places located on the coast where the warm ocean currents flow record higher temperature than the places located on the coast where the cold currents flow. Distribution of temperature. The global distribution of temperature can well be understood by studying the temperature distribution in January and July. In the temperature distribution is generally shown on the map with the help of isotherms. The isotherms are lines joining places having equal temperature. Take a look at figure 9.4. The distribution of surface air temperature in the month of January. A and B show the distribution of surface air temperature in the month of January and July. In general, the effect of the latitude on temperature is well pronounced on the map, as the isotherms are generally parallel to the latitude. The deviation from this general trend is more pronounced in January than in July, especially in the northern hemisphere. In the northern hemisphere, the land surface area is much larger than in the southern hemisphere. Hence, the effects of land mass and the ocean currents are well pronounced. In January, the isotherms deviate to the north over the ocean and to the south over the continent. This can be seen on the North Atlantic Sea Ocean. The presence of warm ocean currents, Gulf Stream, and North Atlantic Drift make the Northern Atlantic Ocean warmer, and the isotherms bend towards the north. Over the land, the temperature decreases sharply and the isotherms bend towards the south in Europe. It is much pronounced in the Siberian plain. The mean January temperature along 60 degrees east longitudes is minus 20 degrees Celsius both at 80 degrees north and 50 degrees north latitudes. The mean monthly temperature for January is over 27 degrees Celsius in equatorial oceans, over 24 degrees Celsius in the tropics, and 2 degrees Celsius to 0 degrees Celsius in the middle latitudes, and minus 18 degrees Celsius to minus 48 degrees Celsius in the Eurasian continental interior. The effect of the ocean is well pronounced in the southern hemisphere, hence, the isotherms are more or less parallel to the latitudes, and the variations in temperature is more gradual than in the northern hemisphere. The isotherm of 20 degrees C, 10 degrees C, and 0 degrees Celsius runs parallel to 35 degrees south, 45 degrees south, and 60 degrees south latitudes, respectively. In July, the isotherms generally run parallel to the latitude. The equatorial oceans record warmer temperature more than 27 degrees Celsius. Over the land, more than 30 degrees is noticed in the subtropical continental region of Asia. Take a look at figure 9.4b, the distribution of surface air temperature in the month of July. Take a look at figure 9.5, the range of temperature between January and July. Along the 40 degrees north runs the isotherm of 10 degrees Celsius, and along the 40 degrees south the temperature is 10 degrees Celsius. Figure 9.5 shows the range of temperature between January and July. The highest range of temperature is more than 60 degrees Celsius over the northeastern part of Eurasian continent. This is due to continentality. The least range of temperature, 3 degrees Celsius, is found between 20 degrees south and 15 degrees north. Inversion of temperature. Normally, temperature decreases with increase in elevation. It is called normal lapse rate. At times, the situation is reversed and the normal lapse rate is inverted. It is called inversion of temperature. Inversion is usually of short duration but quite common nonetheless. A long winter night with clear skies and still air is ideal situation for inversion. The heat of the day is radiated off during the night and by early morning hours. The earth is cooler than the air above our polar areas. Temperature inversions is normal throughout the year. Such inversion promotes stability in the lower layers of the atmosphere. Smoke and dust particles get collected beneath the inversion layer and spread horizontally to fill the lower strata of the atmosphere. Dense fogs and mornings are common occurrences, especially during winter seasons. This inversion commonly lasts for few hours until the sun comes up and begins to warm the earth. The inversion takes place in hills and mountains due to air dryness. Cold air at the hills and mountains produced during night flows under the influence of gravity. Being heavy and dense, the cold air acts almost like water and moves down the slope to pile up deeply in pockets and valley bottoms with warm air above. This is called air dryness. It protects plants from frost damages. Planck's law states that hotter a body, the more energy it will radiate and shorter the wavelength of that radiation. Specific heat is the energy needed to raise the temperature of 1 gram of substance by 1 Celsius. Exercises. Multiple choice questions. The sun is directly overheated at noon on 21st June at the equator, 23.5 degrees north, 23.5 degrees south, 66.5 degrees north. In which one of the following cities are the days the longest? Thiruvananthapuram, Hyderabad, Chandigarh, Nagpur. The atmosphere is mainly heated by the shortwave solar radiation, long wave terrestrial radiation, reflected solar radiation, scattered solar radiation. Make correct pairs from the following two columns: insolation, albedo, isotherm, annual range. The difference between the mean temperature of the warmest and the coldest months, the lines joining the places of equal temperature, the incoming solar radiation, the percentage of visible light reflected by an object. The main reason that the Earth experiences highest temperature in the subtropics in the northern hemisphere rather than at the equator is subtropical areas tend to have less cloud over than equatorial areas. Subtropical areas have longer day hours in the summer than the equatorial. Subtropical areas have an enhanced greenhouse effect compared to equatorial areas. Subtropical areas are nearer to the oceanic areas than the equatorial locations. Answer the following questions in about 30 words. How does the unequal distribution of heat over the planet Earth in space and time cause variations in weather and climate? What are the factors that control temperature distribution on the surface of the Earth? In India, why is the day temperature maximum in May and why not after the summer solstice? Why is the annual range of temperature high in the Siberian plains? Answer the following questions in about 150 words. How do the latitude and the tilt in the axis of rotation of the Earth affect the amount of radiation received at the Earth's surface? Discuss the process through which the Earth atmosphere system maintains heat balance. Compare the global distribution of temperature in January over the northern and the southern hemisphere of the Earth. Project work. Select a meteorological observatory located in your city or near your town. Tabulate the temperature data as given in the climatological table of observatories. Note the altitude, latitude of the observatory and period of for which the mean is calculated. Define the terms related to temperature as given in the table. Calculate the daily mean monthly temperature. Draw a graph to show the daily mean maximum, the daily mean minimum, and the mean temperature. Calculate the annual range of temperature. Find out in which months the daily range of temperature is the highest and the lowest. List out the factors that determine the temperature of the place and explain the possible causes for temperature variations in the month of January, May, July, and October. Example: Observatory, New Delhi, Safdarjung, latitude 28 degrees 35 degrees north. Based on observations 1951 to 1980. Altitude above mean sea level 216 meters. Month mean of daily maximum in Celsius, mean of daily minutes in Celsius, highest recorded degree Celsius, lowest recorded degree Celsius. January 21.1, 7.3, 29.3, 0.6. May 39.6, 25.9, 47.2, 17.5. Daily mean monthly temperature. January 21.1 plus 7.3 by 2 is equal to 14.2 degrees Celsius. May 39.6 plus 25.9 by 2 is equal to 32.75 degrees Celsius. Annual range of temperature. Mean maximum temperature in May, mean temperature in January. Annual range of temperature is equal to 32.75 degrees Celsius minus 14.2 degrees Celsius is equal to 18.55 55 degrees Celsius. Thank you.